Hello everyone. My name is Dr. Ayshika Kapoor and I'm currently working as a deep learning researcher. I recently completed my PhD from IIT Roorkee, where my research focused on designing privacy preserving and communication efficient federated learning algorithms for various smart city applications. I am truly honored to be shortlisted for the second edition of the Women in 6G Best Research Paper Awards. This platform is very meaningful because it recognizes the contributions of women researchers in shaping the future of 6G technologies. For this award, I have submitted three works. Although all three papers have different focuses, they are connected by one common vision. That is, how can we enable intelligent, secure, and scalable learning in future 6G enabled systems without compromising privacy, communication efficiency, or trust? As we move forward toward 6G, wireless networks will not only connect people and devices, they will also support intelligent services such as smart cities, autonomous mobility, environmental monitoring, digital twins, and large scale urban sensing. These applications will generate enormous amounts of data from vehicles, sensors, mobile devices, cameras, and edge nodes. However, sending all this raw data to a centralized cloud server is not always practical or safe. It creates challenges related to privacy, bandwidth usage, latency, energy consumption, and security. This is where federated learning becomes very important. Federated learning allows multiple devices or organizations to collaboratively train machine learning models without sharing their raw data. Instead of sending private data to a central server, each device trains locally and only shares the model updates. This makes federated learning highly suitable for 6G systems where intelligence is expected to be distributed across the edge. My first paper Federated Learning for Urban Sensing Systems, a comprehensive survey on attacks, defenses, incentive mechanisms, and applications, was published in IEEE Communication Surveys and Tutorials. The key contribution of this work is that it brings together multiple important aspects of federated learning, such as various privacy attacks, defense mechanisms, incentive strategies, and real world applications. Mostly existing works, they look at these topics separately, but our paper presents a unified view of how federated learning can be used in urban environments, such as smart transportation, traffic monitoring, healthcare, environmental sensing, and public safety. This survey is important because before deploying federated learning in 6G systems, we must understand both its strength and its vulnerabilities. Our work highlights the risk and discusses defense strategies that can make federated learning more secure and trustworthy. My second paper, K-HashFed, Communication Efficient Federated Learning Through Gradient Clustering and Hashing, it addresses one of the biggest challenges in federated learning, that is communication cost. In large scale networks, repeatedly sending model updates can be expensive in terms of bandwidth and energy. So K-HashFed, it reduces this overhead using gradient clustering and hashing, where similar gradient information is grouped and represented compactly. This makes federated learning more scalable and suitable for resource constrained 6G edge devices. This work was published in IEEE International Conference on Acoustic Speech and Signal Processing in 2025. The third paper, Enhancing Smart Cities with Federated Learning, a framework for secure, scalable, and intelligent urban sensing systems, was published in IEEE Internet of Things magazines. In this work, we look at how federated learning can be integrated into smart city infrastructure to support applications such as traffic prediction, road condition monitoring, environmental analytics, and urban safety. The framework emphasizes privacy preservation, distributed intelligence, and scalability, which are all central to the 6G vision. Together, these three papers they form a complete research direction for 6G enabled federated intelligence. The survey identifies the key challenges, vulnerabilities, and opportunities in urban sensing. The K-HashFed paper it provides a concrete solution for communication efficient federated learning, and the smart city framework shows how these ideas can be applied in real-world urban systems. The importance of this work lies in its strong alignment with AI native 6G networks, where intelligence will be distributed across edge devices and must operate under strict requirements of latency, reliability, privacy, scalability, and energy efficiency. By reducing communication overhead and avoiding centralized raw data collection, this research supports secure, privacy preserving, and sustainable learning at scale. I believe my work deserves to win the first prize because it addresses a significant and timely challenge, that is, how to build trustworthy, communication efficient, and scalable distributed intelligence for 6G and beyond systems. The works are not limited to theoretical discussions or only algorithmic improvements. They provide a complete research direction, from identifying challenges to proposing technical solutions to designing a practical framework for real world deployment. The work is impactful because it can support future applications that directly affect society, such as smart mobility, safer cities, environmental awareness, and inclusive of digital infrastructure. As a woman researcher in the field, I also see this recognition as an opportunity to contribute to more diverse and inclusive 6G research ecosystem. Awards like Women in 6G not only celebrate individual research contributions but also encourage more women to participate in shaping the technologies that will define the future. To conclude, my research vision is to help build future wireless systems that are not only faster and more connected, but also intelligent, secure, privacy preserving, energy efficient, and socially beneficial. I am grateful for this opportunity to present my work, and I sincerely thank the Women in 6G community and the review panel for considering my submission. Thank you.